Look up. You see the towering canyons of Manhattan. Steel, glass, concrete, a city that claws its way toward the sky. That's the lie. That's the beautiful, glittering distraction. The true heart of New York City, the thing that makes it breathe, the power that drives its relentless pulse, is not found in the penthouses or the data centers. It's found down. It's found in the silent, seething, high-pressure underworld beneath the feet of 8 million distracted people. It's in the plume. You've seen it 1,000 times, that ghostly, almost cinematic column of white vapor erupting from an orange and white striped chimney poking out of a city street. It's iconic. It's the backdrop for 1 million photographs, a shorthand for gritty urban chaos. Most people dismiss it as a burst water main or a sewer problem, maybe just part of the city's chaotic metabolism, a shrug-worthy feature of the metropolis. But that steam is not a problem. It's the solution. It's the physical manifestation of a colossal, invisible engine. It is the breath of a hidden beast. Imagine a circulatory system, not of blood, but of pure, superheated energy. A network of pipes, some wider than a man's torso, running for over 100 miles, transporting steam hotter than the surface of Venus, pressurized enough to shatter bone. This system is the life force of the city, providing heat and cooling to nearly every major landmark, hospital, and museum you can name. Because this is not just hot water. This is the power that built and sustains the world's most famous skyline. The Empire State Building? Steam. The Metropolitan Museum of Art? Steam. Half of Broadway's theaters? Steam. This is the story of the hidden steam power beneath New York City, a tale of late 19th century visionaries, 21st century engineers, catastrophic explosions, and the silent, grinding, dangerous work of the people who keep the city's heart from exploding. The New York you never see. The air in the vault is thick, smelling of ozone, hot earth, and a faint metallic tang. It is a humid, suffocating environment that could best be described as an inverted pressure cooker. The heat alone is enough to wilt a tourist in July. But down here, in the belly of the grid, 30 feet beneath the rush hour chaos of Midtown, it's a constant, year-round punishment. Meet Eddie the Fitter Morales. Eddie is 42, but his eyes hold the weary calculation of a man who has spent 20 years wrestling with the temperamental forces of nature bottled in steel pipes. He's wearing a flame-retardant suit the color of mustard, safety glasses that fog up the second he stops moving, and gloves thick enough to handle a hot skillet. And he is listening. You gotta understand, this isn't like the water pipes, Eddie says, his voice muffled by the vault's concrete echo. He gestures with a thick-gloved hand toward a row of colossal, insulated pipes running along the tunnel wall, pipes that are throbbing, not just with heat, but with kinetic energy. Water can leak, water can freeze. This stuff, it doesn't leak, it cuts, it vaporizes. It's a knife made of invisible gas. He's talking about steam at 150 pounds per square inch and temperatures pushing 350 degrees Fahrenheit. The working pressure in a typical suburban home boiler is maybe 15 psi. New York is running on the equivalent of 100 locomotive engines, chained together and buried beneath its streets. The pipe Eddie is inspecting is a 20-inch main, a major artery that services the entire stretch from 34th Street down to the financial district. His job today isn't glamorous. He's checking the expansion joint, a critical piece of engineering that allows the massive steel pipe to swell and contract as the steam is cycled on and off. Think of it. A 100-foot-long piece of steel pipe can expand by over an inch when superheated. If that expansion isn't perfectly accommodated, if the pipe jams against the tunnel wall, the resulting pressure buildup is not a leak, it's a bomb. When we go down, Eddie continues, his head tilted as he listens for the telltale sound of a failing gasket, We're not just repairing a pipe. We're working in the shadow of a colossal, invisible explosion. Every wrench turn, every weld, every bolt has to be perfect, because if it's not, that steam is looking for a way out, and it doesn't care what's in its way. The very existence of this system is a testament to the colossal ambition of late 19th century New York, a city always in a hurry. Back in the 1880s, the city was choked by the soot of thousands of individual coal-fired boilers, one in the basement of every major building. The air was poisonous, the basements were perpetually dangerous, and the inefficiency was crippling. The problem was not power, it was delivery. Enter Birdsill Holly, a visionary from Lockport, New York, who had pioneered district heating, using a central power plant to send steam or hot water to multiple buildings. In 1882, the New York Steam Company was born, seizing a revolutionary idea: centralization. The pitch was irresistible to the city's early titans of industry. We will eliminate your coal chute, your basement furnace, your ash removal, and your constant boiler maintenance. We will pipe clean, reliable power directly to your building. You just turn the valve. It was an engineering marvel that instantly gave New York a competitive advantage. Buildings could be taller, basements could be freed up for storage or retail. The city could grow up because its power source was safely buried down. An immense, privately funded public works that cemented New York's fate as the ultimate metropolis. The genius of that 19th century system is that it's not just about heating the city in a brutal January, which is what everyone assumes. That superheated yeast is also the key to keeping the city cool in a sweltering August. This is the paradox of the steam grid, the silent efficiency few understand. We follow the steam's journey from Eddy's pipe to a modern skyscraper near Times Square, where it enters the belly of an absorption chiller. The process is a kind of industrial magic. Instead of using electrical power to run a compressor, the building uses the massive heat of the steam to boil a refrigerant and a salt within a specialized machine. The high-temperature steam creates a vacuum and a chemical reaction that absorbs the heat out of the building's own chilled water system. It's heat being used to create cold, turning a byproduct of power generation into climate control. This is the green angle. When the power plants generate electricity, a huge amount of thermal energy is normally wasted, but by capturing and piping that excess heat energy as steam, the utility, now Con Ed, achieves a far higher rate of fuel efficiency than standalone power plants. It's a form of urban energy recycling, a hidden system that allows buildings to avoid burning natural gas or oil locally, reducing emissions and improving air quality right where people live and work.
The steam whisperers are the building engineers, the guys who manage the massive, intricate machinery within the basements of major buildings. They are the customers, the interface between the Con Ed grid and the building's ecosystem. They know the subtle sounds, the quiet knock of condensate return, the faint whistle of a pressure drop that signal life or death for the system. But this immense power is, by its very nature, temperamental and prone to spectacular failure. The city remembers, even if subconsciously, the moments when the beast beneath its streets broke free. We remember the 2007 steam pipe explosion in Midtown Manhattan, the one at Lexington and 41st Street, a massive crater, a blinding white cloud, a deafening roar that made everyone think terror. It was not an attack, but a moment when the lifeblood turned against itself. The investigation was an engineering nightmare involving specialized crews who had to approach a crater that was essentially a high-pressure volcanic vent, a massive pipe rupture that turned an ordinary intersection into a boiling geyser. The risk was immense, not just the scalding steam, but the risk of asbestos, because miles of older pipes were wrapped in the deadly material, and the explosion aerosolized the fiber, making the steam cloud toxic. The engineering challenge was a race against time, capping the break, isolating the rupture using a series of complex valve systems, sometimes miles away from the blast site, all without shutting down the power to the hospitals, the subway, or the countless businesses relying on the grid. In the deepest parts of the grid lie the ghost pipes, the segments that run right alongside the city's other arteries. The pipes are constantly battling the city's three other major systems: water, sewage, and, most aggressively, the subway lines, where subway expansion often means rerouting or digging around superheated, immovable steam mains in a tight, three-dimensional game of infrastructural chess. But the key to the whole system is the condensate return, a crucial but less known aspect of the system. The steam, once used, turns back into water, the condensate, and this water is valuable, pure, demineralized, and already hot. The city maintains a second set of return pipes to bring this water back to the plants to be reheated, the closed loop that is the core of the system's efficiency. The workers who clean these return lines, which can become clogged with scale and sediment, are the unsung heroes, along with the highly specialized welders, the underground crews, and the boiler operators at the massive East River Generating Station, where water is boiled into steam in cathedral-like structures dedicated to creating the invisible power. The system today is a mix of 1880s cast iron and 21st century smart technology. They are the engineers developing AI-driven systems to predict pipe failure before the disaster, using fiber optics and acoustic leak detection to listen in for the tiny anomalies that signal a coming catastrophe. Moving from reactive repair to proactive maintenance, integrating the steam system into the smart city concept. It is a battle against rust, against groundwater, against the constant vibration of the trains, and against the pure, violent nature of pressurized heat. For all of it, all they see is a little puff of white smoke. So the next time you walk down a Manhattan street, don't just see the steam plume, understand it. It is not just vapor, it is the exhalation of a gigantic, carefully controlled, and perpetually dangerous machine. It is the legacy of Birds Hill Holly and the daily labor of Eddie Morales. It is the hidden architecture of ambition. It is the power that built the skyline and the heat that keeps the city from freezing to death in the shadows of its own glory. Look down at the sidewalk, beneath the concrete, beneath the rumble of the trains, below the tangled dark earth. The steam is flowing. It is hot. It is fast. It is relentless. It is the silent, essential heartbeat of the world's most famous city, and without it, everything stops.